Hey guys, this is the fourth one, and we are learning how to solve exponential equations. Let's go. Hey guys, and welcome back. This is Franck, and today we are going to be focusing on solving exponential equation. And as you know already, when you solve anything, the goal is to figure out what your unknown is. Most of the time, that unknown is going to be known as x, and we are looking for that. And the golden rule here is whatever you do on one side, you do on the other. And I've already talked about this a little bit on my note 11, where I was looking at solving linear equation, where you learn that addition and subtraction cancel each other out, multiplication and division cancel each other out, and of course, power and root cancel each other out. So if you want a refresher on that, you can check out that note. So this brand new video is going to be adding only one more aspect to those cancellation, and it's going to be the fact that the log and exponential cancel each other out. So in this case, since we are doing exponential equation, you're going to have that the log would cancel exponential, like you've seen in my note 47, where I was discussing properties of logs. And so now let's just jump into some examples so you can see how these things plays out. And so my first example here is going to be the equation 2 to the power of x equals to 64. So our goal here is to get x by itself, and whatever you do on one side, you do on the other. That's the golden rule. So in our case here, since this is an exponential equation, what you would want to do is hopefully cancel out the exponents. So you can do this one of two ways. You can either put log base 2 on both sides so you can cancel the exponents, or you can look at 64 here and ask yourself, is it possible to write 64 as a power of 2, since you have a power of 2 on the other side? And so here, if you do the math, you would see that 64 is actually equal to 2 to the power of 6. So you would have here 2 to the power of x equals to 2 to the power of 6. And so now you can just go ahead and cancel out the exponent on both sides so you can get x equals 6. And the reason why you can cancel the exponents on both sides here, of course, is because you can do the same thing if you were to put log base 2 on both sides. And so log base 2 and the 2 exponent would cancel each other out, and you will just get x equals 6. So canceling the exponent on both sides is just a quick and short way to saying that you are putting log base 2 on both sides, basically. All right, so my next example here is going to be 6 to the exponent x minus 3 divided by 4 equals to the square root of 6. Here again, I said that this is going to be 6 to the exponent of x minus 3 divided by 4, and then the other side here, the square root of 6 is the same thing as 6 to the power of 1/2. And so I'm going to have that, and then I'm going to cancel out the 6, or if you wish, I'm going to put log base 6 on both sides so that I would cancel the exponents, and I'm going to get x minus 3 divided by 4 equals to 1/2. And of course, to get rid of the denominator here, I'm going to multiply both sides by 4, which is going to give me x minus 3 equals to 2, which means that x would equal to 5. Next, I'm going to have here e to the power of x plus 1 equals to 1 over e. That's going to give me e to the power of x plus 1 equals to e to the power of negative 1. Because as you know, if you have a power on the denominator and you move it up, it becomes negative. And so because that was 1 over e to the power of 1, bringing the e on top would make the 1 become negative 1. And so now you can go ahead and put ln on both sides of the equation, or cancel out the e's, and you would get x plus 1 equals to negative 1. That would make x equals to negative 2. All right, let me give you more examples. So my examples here are going to be going up in difficulties as we move on, so just bear with me. So we're going to have next 10 to the power of x equals to 3.91. So in this case, writing 3.91 as a power of 10 will be difficult, and so we're not going to do that. What we're going to do here is simply put a log on both sides, the common log, that's log base 10, and so that's going to cancel the 10 on one side, and so you're going to have x equal to log of 3.91, and this is going to be it for this one. We have x on one side, and we're done. Okay, next example, I'm going to have 5 e to the power of x equals to 23. So in this case, there's a 5 next to the exponential, so I cannot go ahead and just do ln on both sides directly. What I have to do here is go with the reverse order of operation. So I'm going to have to cancel the 5 first, and so since 5 is multiplying the e, I'm going to have to divide by 5. If I do that here, I'm going to get e to the power of x equals to 23 over 5. Now that the exponent is isolated, I can go ahead and do the log on both sides, right? So you never do log on both sides unless the exponent is isolated. If you do it before, it will be more difficult for you to figure things out. So once I have log on both sides here, the log and the e are going to cancel each other out. So I'm going to have x equals to ln of 23 divided by 5. And we are done. All right, so with that, let me give you more interesting examples here. I'm going to have 5 to the power of 2x plus 3 equals to 3 to the power of x minus 1. And so when you have something like this, where the exponents on both sides are of different bases, there's actually no advantage for you to use either log base 5 or log base 3. So in this case, what I usually do is I just go ahead and use the natural log on both sides or the common log on both sides so I can just get things started. So I'm going to go ahead and put ln on both sides here, the natural log. So that's going to give me ln of 5 to the power of 2x plus 3 equals to ln of 3 to the power of x minus 1. And so now I'm going to go ahead and use my power properties from the log, which means to bring the power down to the front. So I'm going to get 2x plus 3 in the front, and then I'm going to have ln of 5 equals to x minus 1 in the front, and then I'm going to have ln of 3. And so with that, since my goal is to solve for x, I'm going to have to go ahead and break x free by removing the parentheses. And so what I'm going to get here as I multiply ln of 5 by 2x plus 3, it's going to be 2x ln of 5 plus 3 ln of 5. And on the other side, I'm going to do the same thing. I'm going to free x by multiplying ln of 3 by x minus 1. That's going to give me x ln of 3 minus ln of 3. And so with that, I have to go ahead and bring all the x on one side and all the non-x on the other side. So I'm going to have here 2x ln of 5. And then if I bring the x ln of 3, I'm going to have to subtract on both sides. That's going to give me here minus x ln of 3. And that's going to be equal to minus ln of 3. And bringing the 3 ln of 5 on the other side will give me minus 3 ln of 5. With that, since I have x here in two different places, I'm going to have to bring it out and factor it. So I'm going to have here x, open parenthesis. If I take out x from the first term here, all I have left is 2 ln of 5. And from the second term here, I'm going to have just ln of 3. And so that should be equal to, and on the other side here, I'm going to go ahead and just factor out the negative just for fun. So I'm going to have here negative, open parenthesis, ln of 3 plus 3 ln of 5. And so now finally, I can go ahead and divide both sides by 2 ln of 5 minus ln of 3. And that should give me x equals to minus ln of 3 plus 3 ln of 5 in parenthesis divided by 2 ln of 5 minus ln of 3. And if you wanted to go ahead and simplify this expression even further, you could go ahead and use the power properties of the log and the product properties of the log to write the numerator as negative ln of altogether 3 times 5 to the power of 3. That should be giving you 375. And on the bottom, if you bring the 2 on the power position to the 5, you're going to get ln of 5 squared, which is 25, divided by 3 because of the minus between the ln's. And so if you did that, this would be as far as you can go. All right, so let me go ahead and give you one last example, which is of course different from what I've given you so far. I'm going to give you here e to the power of 4x plus 5 e to the power of 2x minus 24 equals to 0. Now, if you got something like this, the first thing you should notice is that not all the terms in this particular equation are exponential. Furthermore, the terms that are exponentials have the same base, but different exponent. More importantly, the exponents are multiple of each other. So when something like this is given to you, you should think of using substitution in order to solve for x. And so here, I'm going to substitute the exponent with the lowest power. And so I'm going to have here u, which is my substitution variable, equals to e to the power of 2x. And so if that's what I'm using, then u squared should be equal to e to the power of 2x squared, which is the same thing as e to the power of 4x. And of course, I've squared u here on purpose because I knew that since my other exponential term had a power that was twice the power of the other term, I would have to have u squared in order to get that term. And so now you can go ahead and rewrite your expression as u squared plus 5u minus 24 equals to 0. Of course, keeping in mind here that u should always be positive because u is an exponential function. And as we learned before, exponential functions sit completely above the x-axis. Okay, so with this, you can see here now that we have a quadratic equation. And so now we have to look for two numbers that are adding up to 5 and multiplying to negative 24. And so those two numbers are going to be 8 and negative 3. And so I'm going to have here u plus 8 in parentheses multiplied by u minus 3 in parentheses equals to 0. And so with that, by setting each of those factors equal to 0, I'm going to have on the first one, u equals to negative 8, and on the second one, u equals to 3. Of course, the first one here happens to be negative, so that's going to be an extraneous solution, so I'm not going to care about that. But the second one here happens to be positive, so it's good because u needs to be positive. And so with that, I'm going to go ahead and revert my substitution. And so I'm going to get here that since u is equal to 3, that means e to the power of 2x is also equal to 3. And so with this equation now, I can go ahead and take the ln on both sides. That's the natural log. And so that's going to cancel out the e on this side so that you can get 2x. But on the other side, you're going to get ln of 3. And so now you can just divide both sides by 2, and you will get x equals to ln of 3 divided by 2. And that will be done for this particular equation. And we are also done for this video. And so as usual, if you would like a copy of this particular note, check out the descriptions below. And next time, I'm going to be showing you how to solve logarithmic equation. And so if you have not yet subscribed to the channel, go ahead and do so right now so you don't miss that video. And finally, if you like the way I break down the material, give me a thumbs up and I'll see you next time. Bye-bye.